Alright, we're back with question 3 now. Just took a break to get a drink of water and check the video. So it looks like the image size is coming through okay, but I'll try to be mindful of making the writing portion a little bit larger. So in this problem we have two hosts A and B. They're connected via store and forward switch S, and this connection, this link, is 100 megabits per second on both sides of S. So we have our link rate, which I'll call LR, and we'll call this 100 Mbps. Okay, we have a packet. This packet is 10,000 bits, so it's 10 KB. And we know that the propagation delay from A to S, and thus also from S to B. Oh, okay, sorry, no, these have different propagation rates. So, yeah, let's see what we got here. So we have A to S is 60 microseconds, and S to B is 70 microseconds. This switch begins retransmitting after 20 microseconds. So, okay. So we have 60 microseconds in both directions here, and 70 microseconds in both directions here. The switch begins, so this is 100 megabits per second on the link, and the propagation delay is 60 microseconds, and then thus also 70 microseconds. So let's take a look at this problem a little bit closely. We also know that the time to prop on link 1, 60 microseconds. Time to process at S is 20 microseconds, and time to prop on 2 is 70 microseconds. Okay. So we need to find one last thing, which we'll call time to transmit. So we don't know time to transmit yet. Now, we have a unit here in seconds, that's great, another unit in seconds, that's great, another unit in seconds, that's good, but we have a data rate and we have an amount of data. So to get to the transmission time, we need to take the amount of data we have, divide by the rate, and we can say that the transmission time, T-trans, is 10 KB divided by 100 Mbps. So immediately I'll just say this is 1 KB over 10 Mbps. Okay, so we have here a K and there an M, so we'll call this 1 times 10 to the 3. I'll remove the problem for now. To the 3 divided by 10 times 10 to the 6. Again, this is B, this is BPS. Okay, so immediately let's get rid of that, and we know this is going to be a second. So we have 1 times 10 to the 3 divided by 1. We're going to put that 0 into the power, times 10 to the 7 seconds. Okay. So we subtract, so 7, 6, 5, 4, that's 1 times 10 to the minus 4. Okay. So, pretty simple here, right? We have microseconds here. We have something that looks like, well, looks like 10 to the minus 5 seconds, right? 100 times 10 to the minus 6 seconds. So it looks like 100 microseconds to transmit. Okay. So it's no longer a question mark. We know for sure this is 100 microseconds. So if I want to go from A to S to B, what do we have? Let's take a look at our question again. Now that we've gotten all of our time units in order, the switch begins retransmitting 20 after receiving. So we have to transmit from A, we have to transmit from S, and that's it. So we're going to say that after the packet leaves A, it needs to see 1 transmission time plus 1 propagation time, right? Plus the time to process at S, plus the time to transmit again, plus the time to at 2. Okay, so this is to go from A to S to B. So T total. How long does it take to transmit a packet from A to B? So this is also part 1. Okay, let's group like terms. We have 2 transmissions. So we have 2T trans plus T prop 1 plus T prop 2 plus T proc at S. Okay, simple enough. So this is 200 microseconds, right? I'm just replacing the symbol with the value, plus 60 microseconds plus 70 microseconds plus 20 microseconds. Okay. So what I'll do here, just to be lazy, is group all of this together. So I have 60 plus 70 plus 20, or 70 plus 70 plus 10, which is 150, plus the 200 gives me 350. Okay. 60, 70, 20, and now let's take a look. We have 10 kb. So to actually put all of this out onto the line, this is the same thing. Did I do this wrong? Let's see. Okay, let me make sure that I have my transmission time correct. I'm kind of doing this with all the outtakes. So I have 10 times 10 to the 3 divided by 100 times 10 to the 6. So that's the same thing as 1 times 10 to the 4 divided by 1 times 10 to the 2 times 10 to the 6. So that's 8. 1 times 10 to the 4 over 1 times 10 to the 8, which equals 1 times 10 to the minus 4. Times 10 to the minus 5, right? Okay. Y, let's see, so 1. So yeah, okay, so this is definitely 100 microseconds. Okay, so it's 350 in the one way. What's the round trip time? Well, okay, we have that one-way time. Now if we look at it going from B to S to A, now we have to transmit here and transmit here. So the problem is nicely mirrored. In this case, RTT is equal to 2T total. Okay, so 350 times 2, right, which is 700 microseconds. And that's our part 2. Okay, so that's question 3 in a nutshell. And I will see you again in the next video for question number 4.